Okay, so one little thing about before. Now I have just fixed the. You see that you remember that we saw layout was very ugly. We actually it wasn't loaded. We were using Bootstrap component, but actually didn't show that they were not formatted properly. Now they are, and the reason is that I just forgot one import statement and this line here. Okay, so I forgot to put it in, and but I didn't want to stop to check for the documentation because I wanted more to be focused on the component design. So actually, for using React Bootstrap, we need to import the CSS files that define Bootstrap, and then all the components that use those. Okay, so this line number 8 was missing, and actually was if you check the documentation, it was here saying, okay, when we install it, you can use the components, but you need to import the CSS file here. So this is the statement here that was missing, and now in app I inserted that at the beginning, and so it will apply for the whole application. Okay, so with just this import, the visual say aspect of the application is a bit nicer. We can have the columns and so on. Okay, can be improved, but just to show you what was missing before. Okay, so the idea is we drill down properties from the father to the child. We remember always to have so to be explicit about which components we need and which properties each component needs, and especially when we create a list, we should always have you remember to use the key to help React render the tree. We still need in this mockup actually the buttons for the actions. Let me just spend a couple of minutes on that. And by thinking about, okay, the button should be inside the row of the table. Okay. Um, do we want to have one to put the actions here? So actually, at least I need at least one TD inside which I could put the different actions. Okay, so just remember there was the button uh, for editing, the other for deleting, and the other um for voting up the code. So I could actually put this into a cell, okay? Uh, but maybe this set of actions could be dependent on whether you are logged in or not, or some other type of information, okay? So we could want to separate the part of the component that renders part of the numbers, actually, from the part that renders the actions. So we could have, for example, an extra component that just will render this cell here, just to delegate this information, okay? And if we have one component, for example, we are in answers. One way of implementing it would be to have, okay, one extra table data, and we call, for example, the answer actions. Answer, NSW, action buttons, to be called here with some property. Probably, of course, we will need at least the ID of the action, or maybe the action object itself, just so for which it can recover the action. This could be one possibility. We have a cell in which we render the set of buttons, okay? But from the responsibility point of view, I don't like it very much, because it looks like answer row is rendering data, and answer action button would be rendering actions. So maybe they need different kind of data or information, and so I don't like it very much to have one component that I would call the display component, just show me some data, from a component that will have some logic inside. So in this case, it would be better to split the component responsibility in two. So I have one component for the data display, one component for the algorithm, for the logic. So what this means is that we need to separate maybe the answer row. We want it, okay? Now they are very simple component, but we could have one answer row data, and we could have another answer row answer action buttons, or function. Don't make me mad again. Function answer action buttons. Like that, okay? And so into the data, we could return these cells. And to the other button, action button, we could return the, the implementation of the buttons. And so the answer row would just be a container of the row that will call the two subcomponents. Okay, so we are breaking it down. Maybe in some other part of the page, the answer row data can be useful just for displaying it. So in other part of the application, we don't need the buttons besides. So we have a smaller component which is more reusable because it's more focused in its scope. How can we refactor this? So we need to take the answer row that calls answer row data and answer row buttons. So for answer row, it's easy because it creates a row and then calls answer row data by giving the answer object, of course, and then we'll call answer row action buttons like that, and then close the row like this. Okay. So the answer row, we will open a row in the table and call the row data that creates some cells for the data, and actual button will create the last cell. Answer row data on its turn needs to return for TD, okay? It needs to return this code. But again, we need to return just one element, not just a set of elements. This will be a syntax error because we don't have one single element tree, but we have 4 separate elements. And to make it correct, we should put that into a fragment like that. So we create a fragment that contains 4 cells. A again is const a from props.answers, like that. Okay. In this case, I wanted to show it because we couldn't have put any other elements here. So we are in the children of a tr, and the children of tr must only be a td or th, by the way. So I couldn't just put a div here or a span or anything else. That would create an error in the HTML syntax. Okay, so that's why the fragment is important, in order to return one element tree where the root of the element will disappear when we are creating the HTML. And of course, the rest is it doesn't change. Okay, the layout doesn't change. But now inside actions, we have the other answer action buttons where we can actually create the buttons, and we can reuse it somewhere else, and we'll see later on when we try to add some action. So like in this case, we have only to return one cell. In this case, we don't need a fragment because there's only one cell. In this case, if we want to maybe later on realize it in a different ways, it's okay. We can just modify. We will only need to modify this single component. And now we need to put the buttons. For example, from the HTML, we have a button primary with some symbol in it, So we need to again to go to Bootstrap the documentation for buttons, components, buttons, and we see the syntax is button variant with a color. So in our app would be answer would be a button variant. So button, we need to remember to import it from React Bootstrap. Okay, so that we are using the right component. Variant would be the primary, right? The primary, and in this case would be vote, for example. And it's a vote button, and then we can have the others that are, for example, the variant is warning and danger, and would be edit, and the other with danger color would be delete. Hmm? And like this, for example. Then we need to work on the spacing. Another detail of JSX is that you see that these buttons are touching each other, which is not very nice to see. This is because the new lines, so we are deleted, are eliminated from the code. So if we add these buttons on the same row here, okay, I would have a little space between them, because the space between elements is preserved. The new lines between elements is not preserved. Okay, so if you have strange layout effects in a normal HTML code, white space, so inline spacing or new line spacing is equivalent. In JSX, not, it isn't, so it creates this sort of problems. Okay, so if you prefer to see the space inside, you better put them in the same row and indent them in a different way, or insert an additional space or an additional component with a space inside, and so on. There's a lot of small tricks just to make it right. Okay, but just remember, the reason is that the space is inside a line as preserved at once with the HTML rules, but when a new line is totally deleted. Okay, we are not putting the icons here because I don't want to spend time, but there are libraries for all the icons for also importing the bootstrap icons. We can check in the again the bootstrap documentation about the icons that are available. Okay, so this right now, okay, we learned a bit to compose the page by passing down some information. What is the next step? The next step would be to try to make more interaction, to actually implement some interactivity in the components. And what's the problem with the current implementation that we have? And that we are learning to overcome with a mechanism called hooks in React, which is very specific of the React framework. We have components. Components are functions, and we are very careful that this function should be really pure functions. What does it mean to have a pure function? With the rendering of the function only depends on the properties that we receive, on the props. So we have some props that we received. We cannot change these props, and we cannot remember or evolve in any way. Let me make a simple example. If I wanted to implement a sorting functionality, so sort by date or sort by author, okay, this component can easily generate that because we have a map, or just before the map we do a sorting operation. No? It's not a problem from the algorithmic point of view. The problem is that the sort order should be an information kept by the component. The component should know whether to sort by date or by author, or to sort in ascending or descending way, right? Um, but the component, if I click on sort by ascending date and then by descending date, it means that the component should in some way, who remembers the question, who remembers the sorting order? Okay, the component can only receive some information and then render the table in some way. So the component, the answer display table, should also receive maybe some information from outside that tells us, will tell it what is the sort order that we want. And but from above, there's only app, and app should pass the information. It's strange, but app should decide the sort order and tell the display to apply this sort order. Again, but app has only constant, has no parameters. So everything is fine if we just have to propagate constant values, but we don't have to modify any of them, and we don't have to remember any of them. A good place would be if the table itself could be able to remember its own sort order, so that the table component will render in a way or a different way according to the user actions in the past, according to what the user did before. Okay, so it means that the component itself, some component, should also be able to remember some information in a way that it can be changed. And this concept in React, or in many other cases, is called states. So we want to find a mechanism for providing state to a component. State is just a variable that is remembered across function calls. But remember that also we are in an asynchronous environment, and these functions are not called by us, but they are called by the React framework in the order that they want, that the framework wants. So we must be very careful. We should not just store some data inside the component. State is not just a variable. So we cannot just think of putting inside the answer row some variable, let order is maybe ascending, so 1 means ascending, or -1 means descending, for example. Because even if we find a mechanism for changing the sort order by clicking somewhere, anytime we execute this function, this variable will be recreated with a default value. Okay, so storing a variable inside a component does not create a state. It will create a temporary value that can be reused whenever you want, but inside a single function run. A single function run, when the function is called, we create intermediate variables. We can use these variables in the rendering, but at the end, in the return statement, these variables are destroyed. So we cannot really store information in variables inside components, because components are functions, and every time they are recreated from scratch, and the variable are destroyed and recreated again, so we will always end up with the default value of a variable. Okay, so do we store them as global variables? No. Okay, we don't want to store the state into global variables that then the single components, global means outside of functions, because then we will totally lose control about who is accessing which variable and so on. Okay, so we want to provide an extra mechanism for a function to be able to remember some value across different calls, and this is something that cannot be done normally, and it transforms the function from a pure function to a function with memory, and it can be implemented by a mechanism that was proposed by the developers of React in version 16. So, and it has a generic mechanism for extending, the capabilities of a function outside the domain of pure functions, but in a controlled way. And the first type, there are different hooks. The first one that we are seeing today is the state hook. These are for example, a list of the major or the most frequently used hooks. use state, use effect, use context, and so on. And the other ones are less useful for us, at least. But then there are a lot of libraries that add extra hooks um, for different purposes. Uh, in our mind, I would remember hook as an extension, so an extension mechanism to our components. Let's start from state. Okay, so this is the general view of a React component. A component right now, we know that it can receive some props, can return some element tree made of children, and each size may receive some props. So the part of props we already know about. We receive some props, we do some logic, and we return one or more children, and we can pass properties down to these children. That's what we've done up to the moment. Then now we are adding one block now, the state. State is a set of variables that are owned by a component. So they are just accessible from this specific component, and whose value can be read or modified in a controlled way. So imagine you have an API just for managing the state that is associated to your function. It is stored somewhere inside your function. Okay, this is this block. State is not received from outside, is internal to the component, is owned by the component, but it can be, of course, used to compute the element tree. So to decide which tree, which component, which children to generate, in which order to generate them, which property to pass them, and so on. Okay, so this is the goal of the state. So props are immutable, so I'm receiving them, I can just use these values from a property. I can do anything. I cannot modify them. The state is something local to the component. The state is private to the component, and it can be only modified, is mutable from the component itself through a special function call. The component is rendered in component already. We know we call the function that will regenerate the output. Normally, a component is rendered when the props change or when the state changes. And props and state are input variables to the component, to the function. Okay, so the function is still pure, let's say. So it will always generate the same element tree if the props are the same and the state is the same. But if the props change and or the state changes, the result, the element tree, can be different. Okay, so inside a single rendering operation, a component is still a pure function. Given a prop, a set of properties, given a set of states, the rendering is unique, cannot change. But now we have a mechanism for storing some information in the state, changing this information, and this change may affect future renderings. So we will have two very separate moments: the moment in which you render the output, and this moment, in this phase, the properties and the state should be thought as constant, as immutable values. And then we have a mechanism for updating the state, not the props because they are not ours, but only the state. How do we create a state variable? We create it with a special function which is called a hook. All the hooks are, by convention, are called with the name that start with use. Use something. So use remembers a hook. Use state is to create a state variable, and we use it like this. Use state, of course, is a function that is imported from React library, and every time we call use state, it creates a new state variable. A state variable is just an object, a container, that hosts a current value and provides a mechanism for updating this current value. So use state creates a state variable, and it returns two elements. One is the current value, a variable that refers to the current value of the state. And the second parameter is a function that we can use to update the state itself. Okay, so a state variable is made of two parts, the current value and the function for updating the value. And useState also has an argument, and this argument actually is the default value, is the initial value of the state itself. Let's make a very simple example, okay? Just by modifying our, let's put a small counter in the footer. I'm just making some modification here because we are already so imagine that in our application, okay, we have a footer component, okay, we go into footer, and the footer now contains the number, and maybe we want to count the number of visits, I don't know, or the number. So let's make a fragment so that they can have two paragraphs of text. I should make a column and a row and bootstrap stuff, but so the number of likes. It could be maybe 0, I don't know, okay? So number of likes 0. I want something that where the number can be increased. Okay, so this number is some information that is only useful in this component. We want to change. We want it to be able to evolve. So what I could do is to create a new state. So the information is not just a constant 0, but it is a variable, a state variable that starts from 0, can be incremented, for example. Okay, so creating the variable is easy. So we create a state, we import, so we call the useState function. A useState, of course, should be imported from React. Import useState from React. The initial value of this variable should be 0, and the name of the variable should be, for example, likes, and set likes. So we usually, by convention, we have a name for the variable, and set plus the name of the variable that remembers the function that we'll be able to change this variable. So in this case, the number of likes should be not 0, but likes. Okay, so in this case, we are rendering again. We see 0 again. So what we did is to create a state variable. Three things. useState needs the name of a variable, the name of the function, which is normally set plus the name of the variable, and the initial value, the default value, 0. Now, this variable likes, inside the rendering code, is treated as a constant. We cannot change it. I declared it const for a reason. Okay, and we can use it like any props, any local variables. We can just use the value as you want. Okay, and it's shown here. And if I see the component footer, we see that in the inspector, I have the properties, like make it a bit larger. We have the props of the component, that in this case for footer there are no props, and we have a section with hooks, and we see that we have one state hook with the value 0. If we click on this icon, it will try to report the name of the variable corresponding to the state hook. So it should write, but it's not working right now. It should write not just state, but also the name of the state, which is in this case is likes. So I don't know why it's not parsing. Again, footer, normally it works. But okay, anyway, today is not my lucky day from a technology point of view. Okay, so we have one hook, which is a hook of type state, so it's a useState hook, and the current value is 0. Okay, how can we change this value? The value, as we said, is a property of this component, And so only this component can call the function setLikes. And when does it call it? Well, maybe we want to call this function setLikes when the user clicks on this line, okay, or on some button. Maybe we want to add one button. We can add one button called like. Okay, so whenever the user clicks on this button, we want this number to increase. Very stupid functionality. So what we can do is to assign an event handler to the button. In every HTML or in every React component, we can always associate some event handlers. And all these event handlers are callbacks that are associated to some user action. And they all start with the name on. So in particular, on click, for example, could be an action to be a callback to be executed when the user clicks on this button. Let's see. We can, of course, we need to provide a callback function. Let's make a simple one, console.log clicked. Okay, just to see how it's working. So we have a component, in this case a button, but could be any other component, and we associate an event handler to some action captured by this component. And if we see it, we go to the console, when we see that when I click on like, we have this text clicks that appears. Now it only appears once because the console is optimizing the output, and so it just shows the number besides that has been repeated 4 times. But it means that you see the number is increasing every time I click on like. Maybe we can, okay, it will print once. Okay, so every time I click on this button, this callback is executed. So what can this callback do? It could maybe increase the number of likes. Let's make it simple. We can log it and say, just to see that the code is executing. And at the same time, I could say set likes, I don't know, to 1. Let's make one step at a time because it's more complex than we think. So when I click on the button, setLikes is a function that will schedule the update of the state to a different value, 1. So I wrote the application just to be sure. I click on like, and I see that the number changes to 1. Okay? And of course, console.log worked and so on. If I click on like again, of course, the number doesn't change because it's still 1. So we saw the working of these 3 parts. Okay, we have the current value, and we have the function to update the state value. Now we updated it with a constant value. We could do the same, for example, with another button where the dislike will set to 0 and so on. Okay, so and the rule is that only this component, setLikes, you see, is a local function. So only this component here can call setLikes because it's the only one that has the visibility over this variable. I can use the value, I can change the value myself. Nobody else can do that unless I decide to propagate this current value or this function to another component as children properties, and we'll see that in a moment. Okay. Okay, I have two warnings here. One is that the state variables are not normal variables, and you should never try to modify the state directly. Okay, in this case it will be impossible because we declared it as a const, and it's a number. Okay, so you cannot change a number if it's declared as const. But imagine that instead of a number you create a state which is an array or an object. Okay, so we know that even a const array can be modified, can be mutated. Okay, you can do that. The language doesn't no, block you from doing that, but it's not the right way of doing that. So every time you want to change a state, we must always call the set function with a new value, and this value must not be the same as before, but it should be a new object. Okay, so for example, if I have a list, an array, and we stored as a state, and I want to add one element to this array, I will create a new array with this element added and call setState with the updated element. So every time we should pass new objects and never modify current objects. After all, we are still in a functional world where functions should be pure and objects should never be modified, only created. Okay. So just don't try to play tricks with the state, because if you change the state yourself, React does not notice it, will not update the web page, and probably will also overwrite your modification with the old value because it still remembers the official state. The second warning is that the state change happens asynchronously. It means that we have a phase in which you're rendering the component. Inside this phase, we may decide that we need to change some information, but this information will only be changed at the next render of the component itself. So we render a component, we call a set likes or set state function, then React will change asynchronously in the future this value, and later on the component will be re-rendered again after, as a consequence of the change of the state. Okay, so a set state will never change. If you write set state here, and if you here write console.log of the number of likes, okay, it will be 0. It will be 0 because set likes doesn't change the value, it will only schedule its changement, its update. We can check it if we don't believe it. Reload the application, number type 0, click on like. You see that it printed 0 even after calling setState. So remember, setState is a request for asynchronous update, asynchronous update of the state itself. The third warning is be careful with updating. Since it's an asynchronous request, we should be careful with the argument of the set function. If the argument is a constant or is a value computed from constants, and with constants I mean properties and states and so on, there's no problem. Okay, we compute the expression and this expression will be saved. But what if the value depends on the old one? So for example, I want to write not just 1 but likes plus 1, right? So, and let's comment all these logs. Set likes plus 1, which is what you want. Every time I click on likes, this number is increased. And it seems working. Let's reload it, so it starts from 0. Likes 0, I click, becomes 1, 2, 3, 4, 5, and so on. So it seems to be working, but actually beware, is not the right way of doing it, because if we remember that this is scheduling an update for later on, okay, we have, let me write this in a text So we have, for example, at a given point, likes is 0, okay? Then user clicks. The user click, what does the click do? Schedule the execution of the callback. Okay. Later on, the callback runs. It's asynchronous, so it doesn't happen immediately at the click time. Okay. And this takes the current value of likes, which is 0, and schedules the update to likes plus 1. Then, later on, the update is applied. And so we have the new state variable. Since the state is changed, the component re-rendered. But this will happen later due to state change. Okay, and this is fine. If I click twice, this whole sequence is repeated. Okay, so the user clicks, the callback runs, the user clicks again, it will schedule another execution of the callback, it runs, it's applied, and so on. Okay, and every time it will take the last value of likes that was increased here, and it will increase it and schedule the application of the increase. Okay, this is fine if everything is instantaneous, but if there are some delays or some break conditions, all of these are asynchronous operations, so we can never be sure of their order. Okay, so imagine that the user is so quick that it clicks twice very quickly. Okay, it can do that. Maybe the application is doing something else, and so the two operations are interleaved in some way here. So what happens now? So we are the same things, but due to asynchronous behavior, maybe the two clicks of the user are closer, and the second click is executed before the first one has been totally executed, totally propagated. And may happen because there are synchronous operations. We are not just inside a single function which is synchronous. Okay, we are many functions, many callbacks. So in this case, what happens? The user clicks, okay, schedules callback. The user clicks, schedule callback. Nothing wrong here. Callback runs, takes the current value of likes, which is current value, which is 0. So it schedules to update the likes to 1, which is 1. Then, before the update is applied, the second callback runs for the second click, and it takes the current value of like, which is still 0, because the update, which is asynchronous, is not being applied yet. And so it will schedule the new state to be 0 plus 1 equal to 1. And now when the new state is applied is 1, and the new state applied is 1. So in total, we lost one click, because we clicked twice, but the count of the likes has only been applied once. Because one of the two callback runs was still reading an old value when it's executed. It was still reading an old value because the change had been scheduled, decided, scheduled, but not applied yet. And so it was reading the old value. Okay, so that's a problem. When we have many asynchronous operations, we cannot rely that a value who is current when the callback is scheduled will still be the correct current value when the callback is executed. The user clicked on a 0 here, But this 0 is the current value now, but it could not be the current value in the future, because it may change. So what the trick for avoiding this problem? The trick that React provides us is that the set function can receive a constant, a value, when this problem doesn't exist, or can receive a function that will take the current value at the time of execution of the callback and not at the time of the scheduling of the callback. So the difference would be to write, instead of set likes, likes plus 1, set likes, callback that returns likes plus 1. What is the difference? In both cases, this likes is set to likes plus 1. The difference is that in line 13, the current value of likes is taken when the click is executed. We are in the callback of onClick. So when I'm, let's say, making a picture of the current value of likes. I'm computing the expression, and this expression is frozen. So when I click, I compute the value. The value will be applied later. I compute it now, I will apply it later. In the second case, when I click, I'm scheduling an update. And when this update will run, at that point, I will read the value of light, what will be the new current value if it changed in the meantime, and compute the new value according to the current future value. I don't have the word for that. Okay, this likes is computed when I click, and this likes is computed when the callback is really executed. So it's sort of sometimes I call it old here, old likes, old likes. So just remember that I'm computing a new value starting from an old value, okay, from previous values. But this previous value is actually newer than the current value. So I have a value, I'm scheduling for taking the future value of that variable, of that state, and switching from an old to a new value for itself. So long story short, every time, always, every time the new value of the state depends on the state itself, so the new value depends on the current value, never compute the value like this, because it would risk of working with a stale value. Always schedule the change with a small callback. Okay, so always use a callback when you are updating the state according to the old one. So this may work when we are increasing something. There was an example before. What is that? No, it's not. When you are toggling something from, for example, the example, here we are toggling something from maybe the language. We are clicking on Italian or clicking on English. Every time we click, we switch. So the operation that we do is to replace a state with its complement. True becomes false, and false becomes true. Again, the new value depends on the old value. And so we will never say set English false or set English true, but always set English to a callback that will take the old value and return the new value. So this is just, we need to be careful. So just remember the three warnings that I say is: never modify the state variable itself, never always return a new object when you are providing a new value, and in the case the new state depends on the old value, always use a callback for updating. Okay, So, okay, yeah, we have this counter, but it's actually not useful very much, not very useful. Uh, One thing that could be useful here maybe is to implement the vote function here. Okay, we have a voting function that will change, should change the score, for example. So we cannot implement it directly, but we use it for thinking about how we could do that. This score, right now it's a constant. Okay, can we modify this constant? No, it's a constant. The only way to have some value that can be modified is to store it as a state variable. Okay, and if we are thinking of a state variable, the state variable should be owned by a component. Who is the owner of this state variable? Well, in our model, the owner is app, should be app probably. Okay, because app is propagating information to everything else, to everybody else. Right now, app has defined this constant, okay, this fake state as constant. So since they are just fake values, they cannot be modified. But we need to modify the application so that these values are dynamic, so are stored as state variables, and they are not stored just as constant. Okay, so the question is, where do we store this information? Do we store them here in answer display? Do we store them in answer row? So each row remembers its own values, or the table remembers the values for everybody, or the app remembers the value for everything. To answer this question, we should consider the visibility of the state. The state is a variable owned by a component, and therefore it is only visible by that component and all the components that are children to it, if they are passed as props. Okay, so if the value of the score would be a state inside the answer row, the new value will never be visible outside answer row and its children. And may be useful to also have it visible outside, should be applied generally. Okay, so the ownership of state should be on the top level component, on a higher level component, where we think about all the possible other components in the tree who might need to know this value. Values can always be propagated downwards, can never be propagated upwards or sideways. Let's make a simple example. Imagine that this like button, okay, we want to put the like button here, beside the title. So the count of like is here, but the button is there. Okay, so we want to move the like button from footer to header, but only the button. Okay, so we would have the button here. Sorry, we want to split, okay, these two. So sorry, let me remove this set like, which was wrong. This is working. Okay, this button, this part of the code, we want to move it to the header. We can put a button, it's not a problem putting a button. The problem is that the callback is using the setLikes function, and setLikes is only visible from inside footer. So imagine that we are moving it. So I'm deleting the button from here and putting that into the header. Here, paste. And there's nothing wrong except setLikes, which is not defined here. We are not using the value likes, the value itself here, okay? We don't need it. But the setLikes, how can I, of course, I cannot have another, Okay, another state. If I wrote again const likes, set likes equal to use state here, it would create a separate independent variable. It's not what we want, right? Because otherwise it will be another variable that will be increased here, but we are displaying the old one. If you want to be sure, we can even try it. Sorry, there's a typo here. Okay, now save here and save there. Button, sorry, I didn't import button in the header. So I need to take the, okay. Okay, so I didn't save the footer. Save. Okay, so the 0 is here, the button is there, but if I click on this line, nothing happens. Well, not really nothing. What happens is that this callback, sorry, I can see it in the inspector. If I click on this button a few times, there's some bug here in the okay. If I click on this button a few times, nothing is shown in the page, but if I look at the header component, I see that the state here is changing. Look at this number here is 9. If I click on like, it will increase with some delay, of course, but it will increase. So we are actually using the increasing a state variable. Actually, it's not, but it's not the same state variable which is being displayed here. We need to have only one state variable and one function to update this state variable. And so the only option that we have is what we call the state lifting. So it's a state variable that must be shared between these two different components, footer and header. So the only way for making that happen is to move this variable into the common ancestor of these components. In a component which is in the father um, or on general an ancestor of both components. So in this case, it means that we need to lift the state definition from footer or header into app. We have only this one. So app will take the responsibility of owning the state and providing the children component access to this state variable. What this means in practice is that the use state statement will be moved from footer. I'm deleting it from footer. I'm putting it into app, into a father. Okay, here. Okay, and now it's easy for me, since the footer component only needs to display the state, to provide a prop, likes equal to likes. So I define a state in app, we start from 0, and I give in this value likes as a prop to footer. Footer doesn't own the state anymore. It only receives as a property a constant snapshot of the current value of the state. If I go to footer, now likes, of course, doesn't exist anymore, but I can recover from the property. Props becomes props.likes. Props.likes. And of course, I must receive some props. So I lifted the state up. The state is no longer a property of footer, is a property of app. And footer only receives what it needs, which is the current value. Okay. And so let me see, the errors are use state is not defined in app. There's also import issues. Okay. Okay. So 0 happens. Now this like button is still not working because it's increasing its local value of the state. I should remove also the state creation from the header and make this access the uh, only state variable that has been created inside app. So let me go to header. I must remove this state that has been locally created. And so I'm asking myself, how can I create a setLikes function? I should be able from header, okay, from the header component to call this setLikes function from app. So how can a component which is a child, sorry, call a method, a function which is defined in the father? Well, it can if the father decides to pass the property down to the children. So for example, setLikes equal to setLikes. So in this case, we are not passing a value, we are passing a function. We are passing a reference to a function. And the child may now receive this property and call the function itself. So if I want a child to modify the value of a father, the only way is that the father gives to the child the handle to modify the value, so the callback function, the set function. Okay, a value can be propagated from top to bottom, it's the only way. Any component can change a value and its children will see the updated value. But if I want a child or a future child to modify a value that is stored in an ancestor, I can do that if the ancestor will provide to the children a function for modifying that. So I'm calling, and for doing that, we are passing update functions down to the component. So we are not just passing values anymore, we are passing functions, which are the keys for modifying states. So in this case, when everything is saved, should work. Sorry. So yeah, it should work. You see that if I click on like, now the number of likes at the bottom changes. And from the component tree, I see that, still this stupid error, I don't know. I see that if I click on like, it will increase, okay. If I see the footer only doesn't have the state anymore, there's no hooks here, only receives a props, likes equal to 5. If I click on like, the prop changes from the point of view of the footer component. The prop changes. From the point of view of the header, it only gets a function which is a prop which is a function called setLikes. Header doesn't even know the value, the current value. It only knows when I click here to call this function. And up is the one that holds the state, and this is the 9, the value 9, that is defined and stored into app and is passed down as a props to footer. So what React does is when I click on like, it will schedule the function, the function will change the state, and the new value of the state will trigger the rendering of app, and trigger the rendering of app will render all the children. We'll see that all the children didn't have any props modified, so they don't really need to be rendered again, except footer, for which one of the properties changed, and so this will be rendered again. So when I click here, I'm triggering a render of app and of footer only, because the app as a state variable which changed, and footer as a props, an input prop that has changed. So we have this sort of inversion of control flow. Well, then I normally don't like to do this way because I'm now giving to my children the full control over my state. No? If a child says, okay, plus 100, there's nothing that prevents me from doing that, or prevents the children from doing that. So usually, instead of just giving the keys to your car, okay, I give you the function, do whatever you want. What the top component does is to define some helper functions. So I can decide, I can define increase likes as a callback function that calls the increase use state old likes to new likes plus one, likes plus one, like that. So I define a function that increases the likes, and this function is a callback that when executed will schedule the use state, right? And this function can be the actual props. Not use state, sorry, set likes. Okay. So I have a function that whose only goal is to schedule the increase of the value. And I'm giving to my header not the full control over the state variable, but one function that does this modification. And so header doesn't really need to call or to also even know the current value of the state. It only needs to increase. So it is called, sorry, increase likes, like this. So it's even cleaner. I'm giving my children limited control over my state variable. I'm giving you the callback, the function that you can use to modify in a controlled way my states variables. So it's also it still works. Okay, if I click on like, it doesn't work. Why? On click props doesn't increase likes. Okay, from up. Increase likes, set likes, plus one. Let me just see if this function is called or not. Okay, increase like is not a function. Stupid me, sorry. No, increase likes is not a function. Increase likes. I'm missing a letter. It's a typo here. Increase with the E. We are loving JavaScript because it doesn't require us to define variables. So now it should work. Yes, it does. Okay. So the idea of state lifting is we move the state to the component. So where is that? So here, display here. For example, we move the state to a component that is able to manage the state. This is another example. We have a button group, and every button should be displayed in different ways. Where we have the real state in one component, and the children receive the current values of the state if they need to display it or to compute something with them, and may receive some reference to a function or some functions to modify the state according to how the owner of the state decides that the state can be modified. By the way, if in this case, if we want to modify the likes by having a list of people who clicked or the timestamps in which he clicked and so on, and not just the number, okay, it would be much easier in this case because the header doesn't need to know how the state is encoded. It only needs to know to call a function to modify it. And the same goes for the footer, that only needs to have a value, which may be actually the current value of the state or some value is computed. Maybe, okay, the state is a list of different items, timestamps in which there were clicks, and in this case I will provide only the length of the list, okay, to the children that needs to display the number. It doesn't need all the details. So it's much better if the state is owned by a component, and the component only gives to their children either the state value, the current value of the state, or a value computed from this, from the component that needs to display, or some control function that do some specific modification to the state, always in an asynchronous way to the children. Okay, so this takes some time to master, because actually we are mixing the clean nesting of the topics, where we know where a value should be displayed, where a value should be controlled, and but then we need to put all the logics of managing these values on the common father of this component, and learn how to pass down the component for modifying it. So that will help us do the next step, in which we can actually try to implement something in these buttons. We probably will need, we already understood that we need to transform these fake constants into a state variable, and provide all the functions able to modify these state variables. Take into account that this is a bit more complex, because this state is not just a number, but it's a list of objects, so it needs some careful modification. So that will be the job for next time. So thank you. Oh, I see that we ran out of time, but more or less we finished the main concept. Managing of the state is one of the say most important and critical parts of React. So just take your time to try to understand and make some exercises to understand how it works. Okay. We just still a couple details of how to update arrays of all or objects, but for the moment let's stick with numbers. Okay. So I'm closing here. So I know you have another class right now, and I will upload the videos later in the day. And thank you, and see you next week.